Okay, gonna do a small talk about tracing. First, as Stefan said, my name is Anders. I work at a company called Proactima, where we make a software as a service solution. And also I previously worked at Geodata. So tracing, there are several variants of tracing. You have application tracing, where you look at your specific parts of the code. But this time we're going to talk about distributed tracing. So when you do tracing that crosses network boundaries, typically in a Kubernetes environment, a microservices environment. So I'm going to do a brief overview of the things, because it's not totally fixed yet. There's different specs, there's different providers, there is things changing, and you might have to make some trade-offs depending on what you want. So this is mainly a high-level overview. I have some examples, and just a warning, I'm not an expert on this. I've just done it for us. But basically, so a trace, according to the open tracing spec, is basically a graph of objects. It's a directed acyclic graph, and that means that you cannot have relationships going back, so you get a loop of sorts. So everything has to flow in one direction. So a trace is basically just a logical container that contains spans. And spans is the actual data, and you get one span per thing, per network hop, per thing you want to instrument, basically. And that is what contains all the important bits. So a span will contain name, timestamp start, timestamp stop, tags, the trace context that has some more data, and has an ID that refers it back up the chain. So that way you can create a graph from start to end, so you can follow all your traces down the stack. And tracing, opposed to logging audit, is mostly used for either troubleshooting or finding regression. So if you have a service that suddenly starts becoming slow, or a request that starts getting slower, you can use traces then to see where in your request path or where in your microservices path the change has happened. So as I said, distributed tracing, there's different specs. Once upon a time, the B3 or the Zipkin or the Open Zipkin or Twitter, whatever you want to call it, spec was the original, I think, the most used. It's called B3 today, but it was Twitter that made it. Then you have the Jaeger spec, that's also the Uber spec that Uber made. And then you have two W3C specs. And I think it's the W3C trace context spec that is starting to become the the one that we should be using. The problem, though, is that not every SDK service thing supports all the things, and you can't really interchange them. So if you use one format, you have to use that format for all the things. And then you might have a service or a layer or something that doesn't support that, and then, yeah, like you can't have that included in your stack, basically, in your trace stack. On the bottom here, you can see the B3 header spec. So this is passed on each request as a header, where you have the trace ID, big chunk of number. Then you have the span, so that is the current segment, basically. And then you have a single number, this case 1, that is the sampling, so if it should sample or not. So you can have, in this spec, you can have 0, then you shouldn't sample, 1, you should sample, and you can have a deferred value that says, be ready to sample, but let somebody else decide if you should sample this request. And then lastly, you have a referrer to the previous span, so you can make a graph of all of this. And the same with the Jaeger and the W3C. Everybody has HTTP headers that does the same thing, though, but in different formats. OK, so you want to do tracing, so you need to collect it. Somehow you need to gather up the traces from the different systems. Like most things, there's several ways of doing it. You can either have your programs or your systems push the traces to a centralized system like Jaeger or Kafka or Grafana Tempo or whatever. Or you can do the scraping approach where you run one or more scrapers that goes and collects kind of like you do with Prometheus metrics or, and you can, of course, combine them depending on what your system support. Not sure what's most common. I think the most common one is to run a scraping approach. But you have several different systems that you can collect your traces in. Jaeger, I think, is the most known, most used system. Personally, I'm using Grafana Tempo, which is Grafana's system. Works the same way as Grafana Loki and Grafana Mimir. So you have ingesters and distributors and object store behind the scene. Zipkin has some stuff. You also have like your Datadog and all different cloud providers that you can send your traces to as well if you want to have it outside your cluster or Then you need something to look at your traces. I mean, just having them doesn't do you any good unless you can look at it. This is a screenshot I found on the Jaeger website showing a view of a trace. So you can see each thing is a span. And you have the top one that is the total request. And you then can see the timeline of each of the steps then in your code or in your system or process or however you decide to do it. So each of these could have been a network boundary, but you can also manually create new spans within a process. So if you want to have more granular tracing than just network boundary hops, for example. So again, Jaeger has UI, Grafana has UI, and Grafana can use several data sources. Tempo is one of them, but you can also use Jaeger backend with Grafana as your viewer. And Zipkin has a viewer, I think. Never used Zipkin, so I don't know. And then you need, to produce traces from your things. OpenTelemetry has SDKs for basically all languages that you are going to use. So .NET, Java, Go, Rust, Python, R, whatever you need, basically. And also the SDKs have additional niceties, I like to call them. So this is a .NET example. And it has, so line 6, add HTTP client instrumentation. So if you add that, whenever you create a HTTP client and do a request, it will automatically create a span or collect that for you. Same with the gRPC. So when you use the gRPC client, it will auto collect that. And then line 8, add source, azure.star. All the Microsoft SDKs, or not all, but like the Cosmos DB SDK, the Service Bus SDK, and several other Microsoft SDKs creates spans by default, so you just need to collect them and it'll end up in your stack. And this is, we can do this for all languages, basically. So that is your code. And you can, of course, also make custom activities, as I said. So if you, inside a process, want to add a span for some specific thing you do, each SDK has a way of doing that. So basically, hey, for this part, create a new activity, and it will be emitted as a subspan again of that request. So this is, as I said, super nice if you want to be able to see how changes you do affect certain request parts, or say you change algorithm or change the backend storage system or how you do a request, you can see the effect, or if something breaks, how it ends up. So that's an example of one of my systems. And as I said, you have to make some considerations. So you can see the first two green lines is from our NGINX ingress. So that emits spans. And we are running Linkerd, and Linkerd only supports the B3 spec. So that means I have to run B3. And then you see the Linkerd proxies, and that is each service that runs Linkerd gets two spans because the Linkerd sidecar has a client and a server. So when you do an outbound request, it goes to the server and the client. And then on the other side, it also has a client server. So it hits the server and the client sends it to your app again. So that's why you see the 4 Linkerd proxies is basically from the NGINX to the Grafana pod. So then the question is that worth it or not? What does that give me, have all that Linkerd noise in here? But then you see Grafana, and there you can see they have some internal activities, so things that are not nested are in the same process, basically. And then again, Linkerd, because I haven't turned on tracing on the backend storage for this data source. So that's why it gets cut off when it hits that service. I don't emit traces from that or spans. And today I found out that Cloudflare's tunnels, so if you run Cloudflare tunnels, they support tracing, but they don't support the B3 format. And I run tunnels, so if I want to trace that, I can't trace Linkerd. But if I want to trace Linkerd, I can't trace my ingress point from Cloudflare. So now I have to choose, do I want that or that? So that's, too bad. Linkerd will add support for whatever becomes the official spec when it becomes the official spec. But they won't do anything before anything official is done. So that's life. So is anybody here using distributed tracing? What are you running?
I use Jaeger.
Jaeger. Jaeger is probably the most common. If you run Linkerd, they have a Jaeger component you can start up, and you get Jaeger backend and stuff out of the box. And if you go look online, you get, Jaeger is very popular. Grafana Tempo that I'm using as a backend supports all the different protocols. You can send whatever you want to it. Pretty nice, and it uses your object store of choice, so S3 or Azure Blob or Google, what it's called, as a backend store. And it also has search capabilities, which I think the other one lacks. So if you have 100 gigs of traces spanning a year, you can actually still search it. When they use cloudless functions to search the traces. So I guess it can get expensive because you have to say you want 200 workers to do the searching or something. But So the short is distributed tracing is very nice when something doesn't work as the way it should, or you get a slowdown or anything like that. But you have to make trade-offs, and it can get finicky to set up because, different formats, different specs. What does your stack support, basically? What do you want out of it? Do you want Linkerd or not? Then you have to select B3 format, and then you can't get some other things in your stack, maybe. And then if you want that other thing, then you have to drop something else. So that is the highlight of tracing. Think about it, and be mindful of your choices, because you probably won't get everything you want.